Hey guys, this video will give you a brief introduction of the Lab8, which is MPI. MPI stands for Message Passing Interfaces, and for this laboratory, I will show you this document and our PowerPoint report, and some of the code and the running result. And the first part is to configure the environment, where we need to set up four nodes with Ubuntu 22 installed on it, and later we installed GCC, G++, and Make, and then we installed MPI library from the Intel website. Oh, I close it. Oh, a second. Yeah, here. We register an account and download the MPI library on all of the four, not this one, all of the four nodes, and then we downloaded it, and we installed it, and then we will do this SSH modification so that we can enable our code to run on several nodes. But this is we can do this later. Firstly, we just tried to run our code on one of the nodes, and we do this later. So let me show you the detailed step. And the first step we did is to we configured for virtual machines, and then we downloaded the MPI library, and then we ran the benchmark here, and everything is good and no error occurred. And then we run the MPI hello world program here with the command. We first because that is a project we downloaded, and we use makefile. We type make here, and we type make here, and then we run that program, and we get something like this. The arrow is pointing at, and then we continue to configure the environment by uploading our codes on different virtual machines, and then we try to run this file. We try to test our program with this test file, and then we get the result like this. This is for character count, and this is for word count, and both of them are run on one node. Oh, what is it? Okay, like this. And later we really spend a lot of time on our code, and we actually there was some bug in our program, and we later use some text file like this to debug our program, debug our code, and then finally we get the correct version. And luckily I have already uploaded to the GitHub. Here we can get access to it, and later I will give you an introduction on our code shortly. And we use Google C++ naming and format style, and believe me, I think our team is the fastest one again, because I really spend a lot of time to optimize the code. And that's it. I will show you later. And later I run our code. And later we go to this step. We configure the SSH public key, and okay, I will show you. 1 second. It should be here. We did this on all of the virtual machine, 4 of the virtual machine. Yes, we paste them here, and then we modify the host file, which is here, host, and we modify the file, modify this file on the all of the 4 virtual machines, and you can see. Yes. so that it can recognize different hosts here. And we do it later. Oh, and then we have to test which node which nodes can be accessed on this way. Let's call this node the master node. Okay, so we use something like this host name. If we just want to run on one node, we just type something like this, and we get this one node. And if we type 2 here, and we still get the same thing. And if we type 3, we'll get the 2 of the node. And if we type 5, I will get the 3 of the three other nodes here. Yeah, that's it. And so this means that the 3 nodes are accessible from this master node. And next step, I will show the PowerPoint. Sorry, I'm really tired. Oh yeah, we run the same file, this testing file on multiple nodes, and it will be faster than before. It will just take you see less than 0.1 seconds, and if we run them on one node, it will take 0.2 seconds or so, and this one will take 0.3 seconds or so. And if we run them on multiple nodes, it will take only less than 0.1 seconds, and that's it. And one thing which is important is to ensure that the results should always be the same, no matter how many nodes are used. For example, if we run, if we get something, I'm not talking about the time. I'm not talking about the time need to spend on it. I'm talking about the I mean, for example, the max character count E27758. This should be always the same value, no matter how many nodes we are using. For example, we are using, if we are using one node only, we get something like this, and then we use this -n5 so that we run it on 5 nodes, and we should still get something like this. With the max character count E should always be this value 27758. It should not change, or else the program is wrong. Actually, our program was wrong initially, but later we debug it. We debug it to find the error with something like this, and we fixed the bug. We fixed the bug, and everything is good now. Yeah, and next thing, next thing we started to use Gutenberg 1 GB. We use this file, and I will show you later. And we first run the word count program, and it only took 44 seconds to run all of the things, and and to show you, because there are too many words which occurred only one time, so I comment out these few lines, and then so that you can see the max word count, which is still this word DTG, and which occurs this time such and such. And then we run a character count program, and it will take similar times if we run it on 5 nodes. I mean, which is this is run on 4 nodes. Sorry, and it will take a little longer than this 5 nodes in the here. And this one is run on 2 nodes, and you see, although the timer is different, the result should always be the same. Again, here we should always ensure the result are the same, which is the mean character count is something like this, which occurs 12 times, and it's the same thing here, you see. And we can compare do a comparison with the other things like Hadoop and Spark, and we'll find that MPI. Oh, this one is not optimized. We uploaded some report like this yesterday, and today we still think our program can be optimized, and we spend a whole day on the optimization, and then finally we get something really faster than before, which is like this, because the yeah. Oh, okay, I will show you the code later. Yeah, finally I get something like this, and I think that's all. Oh, this is a question. I think you have already figured it out if you haven't understand what I'm talking about before. If we choose to use MPI, there are a lot of flexibility to enable us to do a lot of things, but you know, it's hard to program with C++, and we code we really wrote a lot of code, you see here, and yeah, nearly 300 lines. And although the two programs are rather similar, it will still take some time to debug them. And you see the, oh sorry, this is the binary file here. Although the program are similar, yeah, but it will still need a lot of time to be debug. And I think if if we need to implement something easier like this, the word count and character count, we should really use Spark, or we should really use Hadoop, or at most Spark. We should not touch MPI because it really takes a long time to implement it with C++, and there may be many strange bugs. Yeah, and to be honest, it is powerful. It is powerful than the layer 2, and yeah, it has higher performance. And that's all about the report. And next, I will show. I will run one time for you this program. First, we run. We start from the hello world. Oh, sorry. Oh, I will first show you the benchmark here. I will run this program, and slash. Oh, what is that? Yeah, you see, this is the benchmark program. I will zoom out so that you can see it, and I will later zoom in again. This is the benchmark program. We just need to ensure there's no error inside it. It will take some time, so let's skip it. And then we started to run this hello world with the hello world program. Oh, I can't see it now. Sorry, but I'm really tired. Oh, here. Is this here? Okay. Oh, I don't want to run it again. Oh, it's finished. It's finished. The benchmark program is finished, and let's see whether we still have it. Oh, we still have it. Good news. MPI tutorial, and I think we should run make not here, not. And where's the make file? Where's the make file? Let's try. Oh my god. Oh, let me skip it. We run oh my, we run make here, and yeah, I first need to run make clean, right? Let me make file. Yeah, we can run make clean, and then we run make again. Yeah, and then we can generate a new MPI Hello World program, and then we run we can directly run it. MPI Hello World, and you see we get the results, which is something like this. And because we are currently running it on the single node, just this master node, and we just have 0 out of 1 processors. And I will later show you a single program. 1 second. I will not use this thing to show you the result, because it will take too much time to finish it. So I will use shorter text file, which is this one, the simple test. You will see, because they are the same. I delete it, and git pull, and list. Yeah, we have it again. Do we have it? No, we don't. Oh my. Where is it? What's wrong? Oh, never mind. I will RM dash RF 542. I would reclone it, and git clone. Yes, we have it now. Oh, sorry, we have it now, which is here. You can see the size of it is rather small than the 1 GB actually. Yes, it's just I don't know, maybe 1 megabytes or so. And yeah, we do the same thing for this one. Oh, Okay, okay. Oh my. I think there are some conflicts and we cannot merge it, so we just reclone it. And for the last one, yeah, we are ready now. So I will this time I will just run the. Oh, we just use some. Do we have the command here? We use something like this to. I will show you this character count, and we use something like this to compile the file, to compile the code. What's that? Yes, we use this file, and you see, I will delete this rm MPI cc, and we don't have it now, and we compile it again, and we get a result, so that we get the binary file again, and we can directly run it, of course, but it will just simply run on I mean one of the nodes, because we directly run it. If we want to run it on other nodes, we have to yeah, well, I'll show you how to do it, and you can just remember this value so that we can compare with the later values to make sure our code is correct. And then we run it on I'll just use this one because this should be the same. If I change this value into 1, and to see which node are we running, we will change this into host name, and to see, oh, we are actually if we type 1 here, we are actually running our code on this machine, and oh, so let's start it. Yeah, you see, it should be the same value, right? And this is also the same value because we are still running our code on one of the nodes. And let's change this value into 2. It should be faster. Yeah, it should be faster than before. You see, it just to take half of the time, and we still get the same value, right? We still get the same value. You see? Do you see it? Oh, I don't know. I don't know why this is. Yeah, I will change this later because. Yeah, because I don't know the reason. I will fix the bug later. But you see, actually it should be 2. And yeah, we get something like this because I think I have already figured out what's wrong with our code. Anyway, I will change it. Because we are not counting the min character, we are just compare with the max character, because I will show you later. And yeah, this is not the same, but this is correct, and those are correct. So let's try to run on the 5 node, and you see only this value is different, but I will show you in the code why this is wrong, and the other value is correct. And this is the word count, and I'll show you which 5 nodes are there. Host name. Yeah, we get the 5 host name like this, and yeah, that's it. And I will show you the code. Yeah, for the following part, let's start with this character count program, and it has several parts. The first part is just to set up some values, and we define a function here. We define function here to read the file and return the file. I mean, there are characters, and we return the file. We read the file into several chunks, and each time we return one chunk of those chunks. And in the main file, we just need to configure this something for MPI, and yeah, we have several tags for message sending and receiving, and we start to calculate the time here, and we read the file here. This is not important. Those parts are not important, and the following part I think is important than before, because those parts are just the environment configuration, and we first broadcast the message for different nodes, no matter how many nodes are there, and later we start the mapping process. If the current rank is 0, we do such and such, and if the rank is not 0, we do such and such. And what should we do actually? If the current rank is 0, it means that we are I'm now the master node, or rank is to equal to 0, something like that, and we just need to send the information to tell the other nodes how many bytes that you should receive. We should tell them, and we tell them how many bytes you should receive, and then we after they received how many bytes are there that they need to receive. You see that we are using the same tag here, right? K map info tag, and we send this K map info tag. The tags are the same, and we then send each chunk inside the file with this tag K map data tag, and in other nodes we receive with K map data tag as well, and we receive each chunk of the file into different buffers, and then we start processing for each node, and we just need to calculate how many character or in this file, or how many words are there in the word count file, and we store we first store the result into something like this local map. Yes, and we store it here, and we count how many characters are there. But later, in order to transmit the data via MPI, we have to store this map data structure into a C data structure. That is something like this, with we just allocate memory with malloc, and we have to save different value inside this local map into the this flat. I mean, this is a flat data structure. It just has some value, right? It has a character and count, and then we print something like this. You see that, and then we go to the reduce process. I mean, for other nodes which are other than the master node, we need to send to tell how many data you should receive at the master node. So I tell them the map size which is here, which is actually the size of the local map, and I tell them how many bytes you should receive with this tag kReduce info tag, and then in the master node, I should receive that information into this variable int len with this tag kReduce info tag. You see that they are the same. This should be the same, or else it cannot be received. And then we started to send each map, which is actually a flat data structure. This character here, this characters here, is just a flat data structure, and we started to send the data, and of course we have to receive it in the master node. We use this tag kReduce data tag, and because we are sending it with this tag, kpreduce data tag, and once I receive the data, which is actually a map from one of the other nodes, I save that I save that map into the global map, which is the final result that I will display to you later. I will save plus some do the addition that from that with that count into the current count, like this, and then solve for map reduce process, and finally we get them. Oh, earlier we calculate the total time, and when we finally get the global map, we'll start to output the data inside the global map, and something like this will start to traverse the global map and show you which character is that, and how many times it occurs, and like this. And then we find the maximum count and display if the current times is equal to max count, we will output that character, and they're the same thing for the mean count, and the total time finally I'll show you. And that's it for the character count. And for the word count here, they are rather the same, except something here. The delimers are different, because the delimer is like this, because we are currently calculating the word, not the character. We should not have something like 3 or 4, a number in the middle of a word, right? So we set them as the delimers, and actually I think it's easier than the character count code, and we use the same thing, the tag like that, and finally we display the output. Yeah, they are the same. I'll run it. I will show you and show you this. I will first compile it. Oh, let me delete it for you. -f MPI WC list. We don't have it now, and we compile it. Actually, we already have it on other nodes, and just a demo here, and we run it. Oh, we firstly run it on one node, sorry. Oh, because currently I comment out the mean word. I don't want to display it because it will overview the result. That's something like this. I'm not sure, because yeah, you see the results are the same, but the time is much shorter, right? The time is much shorter, but the result is the same. Yes, and that's it. That's all for our presentation. Thanks for your watching. Yeah, and this is our GitHub repo link. Yeah, you can see it in our report. Thank you. Bye.